Hi, I'm Dr. Rod Shaw from Math Plus Academy, and here is this week's math treat. We've been working a lot with circles and line segments and things like that. This week we're going to do the same thing, but now we're going to think about dividing the circle into a bunch of little pieces. And the way we're going to do that is by adding points on the perimeter of our circle, and then as we do that, connecting them with line segments, and that will create different regions in the circle. And I have a table here that I've started to help us keep track of what's going on. So here we go. I'm just going to add one dot, 1 point. Anywhere I want on the perimeter, I'll put it there. And there are no other points, so there's no lines for me to connect. So I just have 1 point, no segments, and we have the one main region of the circle. Now, I add another point anywhere I want. Maybe it's right there. And then I can connect those 2 points with a segment. And now I have 2 points, 1 segment, and I have divided the circle into 2 regions. All right, we keep going. Put another dot on here. Boom. Now I connect this one with the other 2. I have to always connect with everything that's already there. So I'm going to add 2 more segments, just like that. Now I have 3 points. I have 1, 2, 3 segments. And I have 1, 2, 3, 4 regions. Okay. Now, mathematicians like to look for patterns. That's what we've been doing in all the math treats, is looking for patterns. So you might be starting to see some already. Let me put one more dot on there, and let's see what happens. And I will say at this point, we do have one rule. When I create this new dot, now I'm going to have, for the first time, a segment that crosses one or more of the other ones. You'll see what I mean. When I connect this with this, I don't cross any of the lines, segments that were already up there. And when I connect without that, again, that doesn't create anything. But when I connect this one with this one, I'm now going to intersect that one. And the one rule we're going to have here is that if we create any of these intersections and then later on create more dots, we never want 3 lines to go through the same intersection point. So that is forbidden as we build this thing up. Okay, so I did create this new little point there. We're not going to count that in terms of our points here. I just want to count the ones on the perimeter, so that's 4. How many segments have I made? And again, I'm talking about segments between the points on the perimeter. So 1, 2, 3, 4, 5, 6, I believe. And then how many regions? 1, 2, 3, 4 on the outside. 1, 2, 3, 4 on the inside. I believe that is 8. Okay, now as I said, mathematicians like to generalize, and the reason I love this is because whenever you generalize, you have to know why you're doing it, because if you don't, you can go wrong. And I challenge you to do 5 dots and 6 dots and make your guesses for what you think is going to happen, and then check to see if they're true. If you're careful, I think you will find that something interesting happens when you get to 6. So I want you to try and find that, and then once you do, wherever that little interesting thing is, then you got to figure out why, and also try to predict what's going to happen when I get to 7 dots and 8 dots, 8 points, and so on. So that is your challenge. Explore circle division. Draw points on the perimeter, connect every point with every other one, making sure that you never have more than 2 lines intersecting in one spot, and then count. Count the points, count the segments, count the regions, and see if you can create formulas or predictions about what these things are going to be. So that's your math treat for this week. As always, just have fun playing with math.